Okay, so what I want to do now we've got that over and done with is kind of talk about design in general and try to just kind of give you a bit of a mindset towards how you should approach this course and how you can do well in this course. And so the mindset that I want you to approach is kind of this recognition of what bad design is and how bad design comes about, right? So throughout this kind of term, I will be showing some examples from what I have found in industry and stuff like that. I've got some really good examples of like bad design, of other approaches that people had, you know, what's the problems that the company I work with had with those problems and what was their final resolution in the end. But kind of before we get to those, is this going to be nice to me? Let's see. Oh, no, I do actually have to update all these. Let me do that now. And I'll show you this GitHub website in a second. There's an entire website of all my Tute materials. You'll be able to see everything and all the answers should pop up nicely. But the thing is that bad design doesn't just like magically appear. It slowly evolves and typically evolves due to time pressure. And so as like a really good example, let's say, you come along and you're writing this Hello World program, right? And then, your boss comes and says, okay, well, actually, I'm going to change this from a main function just to like a foo function, just for the sake that I want to add arguments that aren't just going to have to be like hard to add. So we're just going to add no arguments to begin with. Oh, no, it's not C. And it's just going to be hello world and simple as that, right? And your boss comes along and goes, hey, I want you to write this, but I want you to add an argument, which is like goodbye. And if goodbye is true, I want you to print goodbye rather than hello, right? So, maybe you're new, you're quick or whatever like that. You don't worry about refactoring this too much. You just add a very simple if statement here, right? Now, there's better ways of writing this, but the whole point is obviously to kind of show you that, this way it's still probably pretty okay. Obviously, you could probably just like build the string, but we'll get to that. So, right, you got goodbye, and you're like, okay, this is fine. And then the next step is, maybe they come along and there's another argument, right? And that adds more complexity. And so you add another if statement for that. And then another if statement for that, right? And maybe at this point, each one, you go, okay, normally you'd go maybe 3 if statements in, you go, okay, enough is enough. I'm going to freaking refactor this and make this clean. But the problem is that you have time pressure, right? So if someone comes up to you and says, oh, you only have 15 minutes to add this new option. That's not a lot of time to like make the option, check it, code review, and push it. Maybe you only have like an hour or something like that, right? And so because of that time pressure, you may make a judgment that is more time efficient at that point, right? Just because that's what you have to do, right? Now, what a lot of people don't realize is that your boss may have actually asked like 2 other engineers to do it, and they both may have said to him, no, I can't do that within that time frame. You're going to have to give me more time, right? Which is actually what happens, and it's actually what we find happens to interns, is that basically people ask them to do things, and because they have less experience, they typically say, yeah, I will do that within the time pressure, right? Whereas most people would say, no, that's impossible to do because, it's I'm just going to make the system worse, and we're going to have to pay for that later with technical debt, right? And so you kind of get this like slow progression where you're the person who has to keep making these changes. And at each point you make it more and more complicated. And then eventually you end up with an if statement that's 100 lines, 100 like if statements long, right? You have 100 different cases. Because once you're 20 cases in, it gets too complicated to change back. If you want to go from like 5 or 10 if statements back into like a different factoring, you're now not just changing the behavior of that one new option, you're changing the behavior of every option to that function. Which means when you're testing that, when your QA team testing that, they have to test the full regression testing of that component. They have to test every option. And so now not only are you impacting the dev time budget, but you're also impacting the QA time budget, right? You may also take longer to review. Maybe someone else is also trying to add an option at the same time. So now their code conflicts with your code. And so now they have to update their code to match your code. But the problem is that their code has to go out sooner than your code. They're on a, maybe a stricter time budget, right? Because it's like really needed for a client. And so in which case now they have to make the change before you make the change. And then you have to grab their code. Then you have to refactor their code into your code. And so now you're spending like an extra 20 minutes to do that. And so you can kind of see how these like time pressures build up, and it becomes almost impossible to really refactor this without basically just taking a big chainsaw and cutting the whole tree down and then just rebuilding it from scratch and just taking the cost. So this kind of bad design doesn't start off being a simple thing. It starts off with just a small change that someone does that's pretty innocuous, and then it just slowly builds up over time. And it gets to the point where it's kind of reaching this critical mass where you can't go back. It's like that kind of gambler's fallacy, right? You're at the slot machines, or you're at like a poker table. If you're $100 down the drain, right? You may be like, oh well, I've lost the last 10 rounds. I must win the next round, right? Which is not how probability works. And so you're kind of in this position where you're kind of already down, and so you kind of feel like you have to win. And so the kind of important thing about that is that the same kind of thing happens here. Is you're kind of already down, you're already paying that technical debt, right? You can't really go back. You can't really stop. Because if you cut your losses there, you're going to have to pay for this big refactoring. And, this actually does kind of exist. I mean, typically not 100 if statements, but logic like this can exist in code. Because typically for this exact reason, one person adds one option, then another option, then another option, and you end up with so many configuration options, right? And I can actually show like a really classical case of this, right? And so I'm just trying to think of this way of saying it without like making it too complicated. But yeah, so basically, we had this like system where we had a what we call a portal, which is just basically just like a website that's client specific. So every client gets their own portal. It contains like maybe like some charts for them of like how various scores of them are going, like maybe like money or like satisfaction, for example, or regardless, right? But another thing it did is had this idea of like kudos. And so the point is that you could like leave reviews for other employees within the company, right? So you can kind of go, hey, this person did this really well, this person did this pretty poorly, whatever, right? And the problem with this whole review system was it was massively bloated for this exact reason. At the beginning, they went to them and they said, hey, we want all these 10 features. And without anyone going, no, stop it, we can't do that with that time period. It's impossible for us to do it in that time period. We need more time. They said, no, we'll do it, because it was basically the company was paying a very good amount of money to get it done. And so they got one developer on it, and they wrote this like awful, like just sprawling piece of code. And it's not their fault, right? They were operating under time pressure. It's not to say that they couldn't have done it properly had they had the right amount of time. And so it was an absolute ridiculous amount of effort. The code written was only for that client, basically, so we couldn't use it for anyone else, which is never a good sign when you have like a product that's meant to be kind of universal. And basically, it, in a lot of cases, had the same code repeated 3 times. And I went in about a couple of months ago and went in to refactor all that because I had to make some changes. And I was like, if I'm making these changes, I have to refactor it. Like, I'm not going to take no for an answer. And they said, okay, well, we need these changes. We'll let you refactor it. So I went in and removed like, I think it was like 60% of the code. And what it was just this bloat. So for example, they had an API endpoint, right? Its API endpoint was like, for example, API, it's like a URL, right? And for example, it was like API, I don't know, self-survey, we'll call it. And then it had, for example, survey schema, right? This is the schema if you're the person taking the survey. And then they had another one, which is like survey schema, which is like the one if you're like giving the survey, I guess, like the other person. Because obviously you have one person who's giving the survey and the other person is like the survey's about them. And that's kind of the difference between these. But both of these took a module, like, because, which survey you took was important. So the module here like was which specific survey. But it turns out these codes basically did the exact same thing. And so you could literally just replace it with schema, because there really was no difference between surveyee or surveyor. It's the same freaking schema. It's just a survey schema. But at one point, I'm sure there was a difference, right? Or maybe they were thinking that there was going to be a difference, right? And this is the next kind of thing. And this is the thing about design that's kind of really critical, is that humans are really bad at kind of guessing what the future is going to hold. I mean, just look at any financial crisis. Stock trading is basically just like crossing your fingers and hoping things go your way. I mean, there's a lot of research in it, but like it really is still kind of to some degree like playing a kind of lottery. I mean, no, people do have very successful at it, so there's definitely like some art and skill to it, but it is still quite random, right? And so in a lot of ways, code is very similar to that. You can have skill, you can kind of look at this, you can look at your patterns, you can look at what you think is going to happen in the next 6 months, and you can kind of predict what changes can happen to the code, right? And you'll get better at that. But you don't entirely know what's going to happen. And so what you see is a lot with sometimes with students when they begin is they start to kind of predict a lot. They're like, oh, I'm going to write this code because what if in the future I need this? And so what they'll do is they'll write a very simple hello world function in 1,000 lines. Because what they'll do is they'll have a function called getString. And this will return a string. Okay, right now it's just going to return hello world. Yeah. Okay, just hello world. And then you have another function called output string. Also, I don't know why I start these with capitals. Output string. And apparently I can't type. And this will be like system.out.println s. Right, so this prints out a string. And then they'll have their kind of entry point. You know, a bunch of code, blah blah blah. And then they'll have something that's like string, equals get string, and the code looks weirdly like this. And then they go output string. Right? This is just unreadable, right? Like the fact that you use a string everywhere, okay, maybe it's like get message or something, or like a get hello message and output welcome message or something, like, you know, whatever. I guess welcome message is better. And so it could definitely look like this, right? But the fact is that what they've done is they've kind of expected in the future for this welcome message to change without knowing whether or not it's going to change. And so this kind of expectation has now just made the code a lot more complex. And like, this isn't too bad. But if this happened for every single thing, which is kind of what happens, you end up writing 1,000 lines more code, right? And especially with classes, we'll get into later on, we'll see this as well. And so with OOP, one of the big mistakes that people make with it is, and this is kind of where it gets its bad name, is that people kind of, everything looks like a pattern to them. And it's kind of that analogy to like when you're holding a hammer, everything looks like a nail. And so what happens is they sit down their code and they start looking for problems rather than looking for solutions. And so what happens is they start injecting, they're like, oh, I'm using 1,000 different solutions here. Just you wait, this is the best design bear code ever. Or it's beautiful. It's, you know, and they start using all these like fancy words, like it's domain orientated, whatever the heck that means. And they're like, oh, you know, I can dependency inject testing mock solutions. And they're like, oh, did you write testing mock solutions? No, I didn't. Well, why do you have dependency injection then? Well, because if I ever need to write testing, I've got it, you know. And it's kind of desire for a lot of people to kind of have this complexity. And it's kind of comforting in some ways, but it makes the code a lot harder to work with, and you're going to have a lot more problems. And so always aim for simple. If you don't have to use OOP, don't use OOP, is basically the hint, right? So OOP is a great solution, but you first have to identify a problem for it. And so just wildly applying it is actually going to get you worse marks in this course. And so we'll kind of go through this a lot more in future, and you'll actually find it's quite nice because you'll kind of just be writing code as you normally write it, but then you'll be like, oh, this is really clunky, this is really ugly. Oh, I can use OOP here, I can fix this up. And so let's just kind of begin with a very simple example. This will most likely run over time, by the way, which is fine because it's the first one and there's very little in the lab that's, you know, it won't take that long to get through it. So this is the website that typically, that's fun. Did I not update one thing? I didn't. Yeah, I forgot to update that file. So let me just do that now. Shooter. Oh, you know what? I'm just going to, you can just close those. For whatever reason, it's thinking that they have to exist. Sure, go ahead. Okay, that's fine. We'll just read through this in the meantime. And so what I want to kind of begin with is asking you guys some questions. Now, normally there's a nice thing here, and as you can see, there's a bunch of stuff here. I've got design patterns. You can kind of go through these if you want. And there's also some pretty cool stuff. This is mostly from previous terms, so I can't guarantee how necessarily awesome this stuff works. But there's a bunch of stuff here. A lot of stuff is for C and stuff, but some of it's relevant. There's home computing. This is images. If you prefer images to following the kind of non-image style, and it kind of describes that, set everything up. Is anything else that's important here? Nope. Okay, sweet. So once this finishes, I'll come back to it. But for now, let's just go through this notes here. We can hide up the answers. Okay, so the first thing is, can anyone tell me what the similarities and differences between C, Python, and Java are from your experience? You've only had like 2 lectures, I think, so yeah. Exactly, yeah. So for example, you have like x equals 1, you can go x equals like a string. Anything else? That's a good thing, yeah. Yeah, that's not good. Not necessarily a good thing, but yeah, it's a good point. So C and Java have semicolons, Python does not. What does Python use as its way to determine what's a new line? Yeah. C and Java have, so BJ said C and Java have pretty similar syntax except for the object orientation. Yeah, so it's kind of what I would call the curly brace syntax. They kind of have similar ways of denoting blocks or lexical scopes. And a lexical scope is just a fancy word for saying anything that lies in between these 2 curlies, right? Or in Python, anything that lies between these kind of indentation here. So whenever you indent in Python, we call that a new lexical scope. It's just a fancy word because people like fancy words. Anything else? Yeah, well, kind of. Java kind of has pointers. We'll get into that a bit. So Java and Python have classes, where C has only structs. Yeah, that's a really good point. So C structs are value only. So they're always passed by value. C is actually an entirely value only language. So what that means is that everything in C is always passed by copy. So even pointers are passed by copy, which is a little confusing. For example, if you call a function like this, what happens here is you're not passing x by reference. What you're doing is you're making a pointer to x, and then you're copying the pointer. So everything in C always copies something, which is why we call pass by value, right? Whereas in Java, you actually pass things by reference, which means that you basically have like a hidden pointer to things. Okay, Java and yeah, that's what he said. Java and Python have garbage collection. Yes, so garbage collection is pretty interesting. It's actually kind of complicated, and I have done a lot of kind of interesting look into research and stuff into it in the past. I definitely recommend looking into it. It's pretty cool. I can push this. And you have things like generation, garbage collection, and stuff like that, and it's actually pretty complicated. There's actually a decent post on the ed that I did sometime recently. And if you want to learn a bit more about some of the garbage collection, the issues in Java with garbage collection, and why you have to use .close for scanners and stuff, this kind of goes through it. And yeah, so garbage collection is really interesting. So basically, it automatically manages memory entirely for you. And Java needs a main function. Yep, that's good. And C has kind of a similar main function as well. You don't need to compile Python. Yeah. One thing I think people always get confused about is this idea of interpretation versus compilation. So basically, coming from someone who's done a lot of compiler work in the past, a lot of it is just kind of gatekeepy, and really there's no real distinction between interpretation or compilation. So Python actually does compile its code in some way, but it compiles it when you run it. So it's really kind of interesting that way, in that what it does is when you run Python, it converts it to bytecode, which is typically represented as .pyc, or Python cache, or cache. I don't think anyone says it that way. Anyway, a little eccentric. So you have this kind of concept of this kind of cache of these kind of compiled Python, which is just bytecode. And bytecode's kind of similar to how Java works. It's a bit simpler. It uses a stack-based orientated bytecode, which is the same as Java. And then that bytecode's picked up by the interpreter and runs the bytecode. So effectively, there's still some kind of compilation involved. But typically, we've wrote interpreted languages ones that kind of require some kind of intermediary layer to talk to a processor, right? So it's not like producing raw assembly that kind of gets run by the assembler on the CPU, or whatever. Okay, so that's pretty simple. I think that covers everything. There's probably a few more here. So types. Java C has pretty bad support for OOP, which we may do today. We'll see. Who knows? Python doesn't force OOP as much as Java does. So Python's much more flexible in terms of its paradigms. Public, so everything in Python is public. You can't stop people from accessing things. In Java, you can use private to stop people, or in C, you can use opaque pointers, which is basically where you put the pointer in .h file, but you don't put the type in the .h file, right? You probably have seen that in 2521, right? Java has the static type system, and so does C, where Python is dynamic. And static versus dynamic is basically talking about whether or not the types change over time. Java is more strongly typed than C, and C is more strongly typed than Python. There's always a bit of contention around what strongly typed means, mainly because it's very badly defined in academia, but roughly it's kind of a relative term. It's not an absolute term. So C is really not that strongly typed. You can definitely mess around with types in C, and the compiler will just trust you, because the compiler clearly has had some issues in its past, because you're like, hey, here's a pointer to a float. And then you're like, no, it's a pointer to int. The compiler just believes you, and it will just do as you say, right? And those kind of massive issues on certain processes and stuff like that, and type punning is kind of very complicated. Okay, manual management. We also talk about maybe a bit about the JIT. I don't really want to talk about JIT this time, but JIT basically converts the Java bytecode to machine code or to assembly as it runs. And so the idea is that you're kind of getting this faster performance over time because it's coming closer and closer to C. Python actually has that as well through something called PyPy, I think, or MyPyPy, something like that. Okay, so can anyone tell me what a class is compared to an object? Class is like a blueprint. Object is like an instance of the class. That's a great idea. Yeah, that's a great way of saying it. Class is like type. Yeah, so class is like the type. It describes kind of what's inside of the object, or kind of what the object kind of is without what it physically is. A class contains objects. Yeah, so class can also have static objects in it as well. So static members that can contain data as well, right? So classes are kind of like blueprints that describe what an instance is. Yeah, let's not get too much into type theory there. That's fine as is. Okay, how do C, Python? Oh, that's fine. Honestly, I'm not gonna go too much into that. Every language is a tool, and they're all fit for different purposes. You may hate Java at the end of this. You may learn to appreciate it in some ways. But everyone has their own favorites, so keep somewhat open-minded. An IDE is just a way to debug, program, and compile, and all that kind of stuff. So we're going to look into the scanner, and then we're going to look into, we've already kind of done this. We'll look into Shout in a second. So we're going to just do a bit of coding now, just a very small amount, so you can kind of get some introduction to some of this stuff without going too crazy. Okay. So we're going to begin with sum. So the first thing that we have here is that we're going to read in from standard input, and we're going to read in a bunch of space separated integers, right? So for example, 1, 2, 3, 4, right? Pretend this is standard input rather than just the command line. Maybe I could just do I don't know. I remember there's somewhere you can make it read from standard input, something weird like that. It doesn't really matter. Who cares? So you kind of have some kind of standard input there that will work. Is it cat? Is that what I'm thinking of? Yeah. It's 1, 2, 3, 4 is going to be a standard input, and it's going to add these up and print out the result. Okay. So the first thing we need to do is we need to actually grab system in. So in C, you'd probably write something like read, if you know what read is, or fread, or you would just use like fgets, if you remember fgets, or fgetchar, or something like that, right? Or fgetc. I never always remember the exact names for things. Okay, but in Java, it's a little bit more complicated because Java likes abstractions. So the first thing we need to do is we need to define what's called a scanner. Now, a scanner is basically just some way to read in from standard input, or read in from any file or any kind of stream generically. So we're going to define a new scanner and we're going to capture system.in. Now, this is your standard input. Now, the thing about Java is a lot of these things are arcane. If you've never dealt with anything like this before, you're like, how the hell do you know what system in is? How the hell do you know what any of these things are? And most of the time, it's Google. Google will help you a ton in this course because the complexity of a lot of this stuff comes from never doing it before. And so being able to Google and being able to research things is really useful. So for example, if someone uses something like a map, you can just say map Java, and immediately the first tutorial, I'm almost certain, will go through a very little amount of information to show you how to use it. Right? This shows me how to iterate through it. This shows me how to add stuff to the map. This shows me how to get things from the map and everything, right? And so typically in most cases in kind of Java and Python similar too, research is kind of really important. Unlike something in C where a lot of the stuff is kind of there's very few functions and it's mostly just about like knowing how to write code generically. Here it's like how do you piece together code. Okay, so the next thing is to write in some kind of way to read in this line. So just the next line is fine, right? So this will read in the next line of input and put it into this variable here called line. So then what we want to do is we then want to split this up, right? So the way we're going to split this up is into an array. And we're going to call these maybe values. And this is going to be called line.split. And we're going to give it a regex. We're just going to use space. Now regex is very fancy in many ways. For example, the ability to give it like very kind of complicated looking things. So regex is this really powerful tool that I actually recommend people always learn because it's very useful for searching for things. Especially when you have like a ton of files and you're trying to search for a certain pattern. It basically lets you do pattern matching. So for example, you could say, hey, give me everything that's A or B. You can just write like that. Or you can say, hey, get me everything that's like ABC or BCD, right? And then you can do all these like kind of crazy like lookups and you can say, hey, repeat this as many times as you can, right? From 0 up to infinity, right? Until you stop. And you know, /s is just white space. You don't need to know any of that in this course though, but it's kind of really useful. So regex, which is called spelled like this, is useful. And will save you a ton of time. It's a bit of a nightmare to use though. So the next thing that we want to do is we want to iterate through this values array. Now in C, you'd probably write something like this, right? I mean, you probably wouldn't write values.length, but you know, you'd maybe do like string length or something. I mean, this isn't a string. You'd do like, you'd have some kind of length probably passed along with it, or maybe it is like a null terminated array of strings, in which case you'd maybe have to have some kind of like pointer value that points to the end. In this case, just doing like this is fine. And then here, all we have to do is, if we want to print out the sum of those items, we just have to convert each item to an int, and then we're done. Right? So simple as like total equals 0. Total is plus equal to integer dot pass int values of I. Right? So this is how you typically write it in C. And then you could just print out the total at the end. But in Java, there's a slightly nicer way of writing this, right? So let's just print out the total first before we do anything else. And so the first thing that we can do here is we can use something called like a for range, right? Let me just actually comment out this entire section. So C styled, and then we're going to write like a Java styled. We're not going to be that much overtime. Yay. Okay. And we're going to write like some kind of like, I don't know, value sure. And we're going to write it like this. Now, this is actually kind of similar to how C++ does it. If you have any remembrance of that, if you've ever done something like that before, it's somewhat similar to Python. You can think of this as like a for loop where you say for in, for like value in this. And this is what this kind of means. This is kind of like an in, right? So for every value in values, we want to do something, right? And we'll learn about something later on, which is something called streams. And now I'm not really going to cover this in any detail, but I will show you off just so you can be like, wow, that's really cool. Values. And then map integer. And so what you can do is you can like write these very kind of complicated things, and that's your sum, right? Wow, you know, this is actually like the exact amount of lines, right? But the point is that you kind of get these extensions over time. So you start off with something really simple like this C style loop, and then you go to this Java style loop where you're saying for every value in this array of values, right? And then we can kind of get to this final stage, right? Which is probably not going to be covered that heavily in this course, but I will mention a couple of times, called streams. And streams are very functional. This is not really OOP anymore. They're not that functional, but they're a little bit more functional than typical Java. And the idea of how they work is that basically you have like, you convert your array, which maybe looks like 1, 2, 3, into a sequence. So you have 1, and then you have 2, and then you have 3. So rather than like having absolute offsets, they have relative offsets. So what you'd have is you would have 1 before 2 and 2 before 3. But you couldn't say like 3 is at position 3. Like that, the positions no longer matter. And so when you're kind of doing this stream, you can kind of think of like having like a water stream that passes through. And for each item in that water stream, for each molecule, you're filtering out things. So maybe you remove all the, bad stuff in the water, like a water treatment plant, or maybe you insert fluoride, or, you insert vaccines or whatever into the water stream. Oh, there's a question. I zoned out about the checking out. I'll talk about package. The difference between next, I'll talk about that. Do you recommend Java doc website? Powerful but truly disgusting, like JavaScript? Yes, like JavaScript. I wouldn't say they're purely disgusting, because I think if you can write them well, they're amazingly beautiful. But also, I'm a very functional boy. I like those kind of stuff, mainly because it's fancy, and I think the fanciness makes it like nice. Makes me feel like slightly smarter than I am. So, oh, Regex truly disgusting. Okay, yeah. Regex is awful, just like JavaScript, pretty much the same style. Yeah. Okay, so the difference between next and next line. Next, actually, we can just look up the docs. So the thing about this is you can mouse over any of these and it tells you. So this returns the next complete token. So basically, typically this will just be like a single character for memory, but it depends on what's defined by a token, which I think you can define in the system. So you can actually right-click this and open this up and look at the exact code. So ensure open, make sure that the file is open, clear caches, basically just make sure that like all buffers are flushed. You can ignore that. It basically grabs the next token within the buffer, make sure that the token exists. If the token is not complete, it will read the input for the next token, right? And then else it will throw an exception. And you can look through this code if you want, and you can read all this code. Yeah, so definitely it looks like you can give a pattern. You can kind of define some kind of matcher. So in this case, it probably is just going to be the next character, but it looks like you can actually tell the scanner what to look for. And you can say, hey, look for this specific pattern, and next will return that specific pattern. Package is kind of like the name of the file. It actually refers to the folder of the file, as you can see here, and it kind of is like a grouping. So what that means is you can kind of group multiple classes under like one umbrella. And so that way you can kind of refer to them all under the same kind of thing. So it's really just a way to kind of group code that works really well when you have a lot of files, because you can definitely have a ton of files. I think a really good way of showing this off is probably just looking at like a slightly more real example. This was for a previous offering last term actually, but we won't be using it this time. It was a Java painting application that I wrote in like a couple hours to show off like kind of how a real application looks, and we kind of went through modifying it, but everyone kind of found it a bit complicated, like it was a lot of code. But it's a really good demonstration of how packages work. So what happens here is you can see we're broken down to a sequence of packages, and each of these packages have everything in it. So these are all the states of the system. So for example, are you performing an action? Are you, for example, dragging, or are you whatever, right? And then you have all your strategies, which is like, what tools are you drawing? Are you drawing by freehand? Are you erasing? Are you doing circular tools? And so it kind of lets you group stuff in that logical kind of way. Okay. Array of strings. Yes. So you may have seen it in C like this. It's the same kind of thing. Don't write it like this, write it like this. So arrays belong to types in Java, whereas in C, they were kind of like this property of the variable in some kind of way. The main reason why is because arrays in Java are actual types. So in C, arrays aren't really types. They're just kind of like a compiler abstraction of like a pointer. But in Java, they have real types, and they have like functions that you can call on them, and they have properties like length and so on. A recommended Javadoc website? Not really. Just I guess the base documentation is pretty good. Oracle is pretty decent. So like all this stuff here is pretty good. I often just Google things directly up, and I'll probably see me do a bit in the course, or mouse over things. It's very useful. IntelliSense is very nice as well. So anyways, that's basically your sum function all wrapped up, and we're probably going to spend... the array is not a property of string. String array is its own type class. And we'll go into something called generics later on, quite a bit later on. And generics is basically this concept of type parameterization. Jeez Louise, that's hard to say. And the whole point of it is that basically you have this kind of generic blueprint of a class, and you have this like type you can swap in and out. So you can say, hey, this can be any type, and the code still works. And that's kind of how classes work. So what you have is you have like one single array class, right? Array T, right? And this is kind of analogous to T array. And then T can be whatever you want, and the behavior is still the same, right? So you can kind of define this like generic kind of array of type, right? And as a kind of an introduction to that, there's something called an array list, which you may or may not have seen yet. And array list kind of has this generic. So you can see here, array list is just one array list type, but this can have any type in it. So you can have an array list of integers, an array list of strings, or whatever. Now this is a couple weeks ahead, so just mentioning it for the fact that someone asked it. So if you don't understand any of this, don't worry about this. We're going to come back to that, right? Okay, let's jump over into Shouter and kind of go through that. Just because it may give you a good understanding of how this stuff all works together. Okay, so sometimes I like to do a bank account example, but I'm not going to do that because time. We'll go to about 20 past. Shouldn't be too much over time. Okay, so we have the Shouter class here. The first thing we do is we always define a package. Now the package here is just going to be Shouter. Because it's just going to be defined by this. Now, let's just make sure we add this to source path. There we go. We automatically add everything to the source path for you. Also, this is a very good point. I'll come back to this resource leak. But we always add the source paths for you, but you can always add them yourself if you want. Anyway, so let's go through it. So we have the Shouter class here. It's pretty straightforward as is. And what we're going to do is basically just going to store a message. And we're going to take in this message through something called a constructor, right? And then what we're going to do is we're going to add some functions to it. So for example, to get the message, and maybe to set the message or whatever. But let's first look at kind of what this is. So this is kind of similar to C. So for example, if I open up shouter.c here, right? You'd probably have like a hash include, some Shouter file. But anyway, we'll just put everything in the C file just for the sake of it. So you would have like type def, struct, Shouter. I mean, I typically would write my classes like this, just out of some kind of style. Because I always use pointers. I don't ever like presuming pointers. Anyway, And you'd have some kind of like class like this. So then within this, you'd kind of have some kind of string message like this, right? Now, modifying this message is probably not something that we want. So this probably could be a const char. And so what you have is you have some kind of message within this structure, right? Same as this. The difference here is that this isn't private, right? Anyone can modify this. This is private. Only this class can touch this. The next thing we have is we have this kind of constructor. Well, we can have the same kind of constructor in Shouter in C, right? We'll just have like a, not public, a void, or typically, I don't know, it doesn't look static, a void, I don't know, Shouter in it. And what this would take is this would take two things. The first thing it would probably take is a Shouter, which I'm going to call this. And then the second thing it's going to take is a message, right? As you can see here, we have two things. We have a this pointer and a message pointer, right? And so therefore, it would just be this.message equals message, which hopefully eerily looks similar to this, right? And so that's what this is here, right? This is just a pointer to the current class. That's all it is. Now, I say pointer because what I mean is that if you modify it, you're going to modify everything that's looking at that. Like it's not a copy. You're not copying the struct, right? There's no such thing as really pointers in Java, but they're called references. So what this means is if I pass this class to another function and it modifies this class, it's going to modify my copy as well because we're sharing the same copy. Because I passed a class by reference. So rather than copying the class and saying, here's your copy, I tell them where the class is and we kind of share it. And so to kind of keep going on, for example, you would have like a setter here, right? And it'll be like this message equals message, and you would have like my brain trying to write two languages at once. And you kind of have this like similar style here. I'm not returning anything. And so that's typically how that kind of difference would work. And here you could just modify the variable, or you could define functions to modify it. Yeah, it's exactly like self. Self, this, same thing. And the next thing is a shout a message. So for example, if we want to shout the message, right, it would be like system.out.println message dot, I want to say to upper. Yeah. Right. And so what that's going to do, just to make this a little bit more balanced, is it's going to print the message in uppercase. So if I write a arg array like this, right, and I kind of write a similar thing here, printf. That's the one I want. Now it's going to be kind of hard for me to print this to uppercase without like a lot of annoyance. I guess I'm just going to do like a for loop. Sure. Right, and so you do something like this, you know, to iterate through the string, and then once you're at the very end, it's going to stop, and for each character you can do like a put char, probably including some kind of, don't care too much about the specifics here. Doing something like to upper, or was it called upper? I don't remember. It's like int types or something, I think is where like upper exists. Anyway, it's called to upper, I'm pretty sure. And exists like somewhere in the library, C standard library somewhere. I don't know, maybe stlib or somewhere. Who knows? Anyway, so we're just going to pretend upper function exists. And so what that would do is that will convert to upper. Maybe there is literally no to upper. I thought there was. It doesn't really matter. You can always just like check if it's within a certain character range and add the characters. You know, you've done that in 1511. Hopefully you can kind of somewhat remember that here. It doesn't really matter. So the point is the code is reasonably similar, but here you have all these like helper functions. It's like very easy to add functions to things, where in C you have to do things a lot more manually, right? And the big difference comes from when we create the class. So in Java, we have this term called new. And every time you see new, I want you to think of malloc. Because what new does is two things. It first mallocs the memory. Again, it's not necessarily malloc, it's like garbage collection. So like it most likely already has allocated that memory and already has like a specific section for any new memory, which is kind of how malloc works anyway. But anyway, guys, so it allocates the memory for the shouter. That's the first step. Also, int main. Again, first step. Right? Mallocs the memory for the shouter. The next step is initialize the memory. So these are two different steps. Again, should just be shouted here. But these are two different steps that occur. But you may notice, oh, I actually need to give a message to initialize. That's probably a good thing to do. What's the difference between shouter and set message? So set message allows you to set the message after it's been created. Shouter is a constructor, which means it's only done once when you create the object. Why is the P in the loop a constant? It's not a constant. A constant would technically be like this. That would mean that you can't change P. As you can see here, you can't change P because it's constant. This just means I can't change the value of P. So for example, I can't say like P++, right? Because it's a constant. Like the character is a constant, not P. It's confusing. Yeah, exactly as I answered. Yeah, honestly, welcome to the land of say. Then you get to like function pointers and it's a nightmare. So like I used to go into like vtables a lot. So I would like show how vtable was created, show how like inheritance works and stuff like that. But honestly, you guys don't really need to understand too much about that. I will kind of briefly mention it next time for the sake of like understanding how inheritance kind of works. So you can understand that basically in Java, every function is like a variable. And so when you have like subclasses, as you'll learn about very soon, you're just changing a variable. But we'll get into that later. But I don't really want to go into as much depth as I've done in the past because I think it's a bit too, it just gets too complicated in some way. Anyway, so the big difference here is that you kind of have this malloc here that's like this new, and then you have this initialization, right? So for example, if you want to set the message, it's just shouter.setMessage, and you can change the message, right? One thing I would always say in Java as we learn is that having setters and getters is not necessarily a good thing, and we want to avoid them as much as possible. Because basically, by having these setters and getters here, it's almost like having this as being public, right? Which is kind of bad. So the point is you eventually kind of classes are meant to encapsulate that behavior as much as possible, right? So you don't really have to have like a ton of mutation, right? And what you'll typically see is people kind of combine multiple setters into one, right? And so you kind of have this like logical combination of behavior. Awesome. So that's basically everything here. We have this struct, we have this class, we have everything, we have this main function, and we can press the run button and run the code without hopefully pressing that. And, you know, hello world, you know, shout on top of our voice, right? And we're basically done. You can kind of see that the similarities between them are quite high, right? So really what it effectively comes down to is that in Java, you lose some kind of choice. But by losing that choice, you get like consistency and just kind of get a somewhat nicer experience. Because the big thing about C is here, you don't necessarily have to malloc this. You could convert to a pointer. You kind of get that control, right? You kind of lose that control over here. Are there any other questions about what I did here or anything in specific? If not, what we'll do is we'll just jump into the lab and we can begin there. Awesome. Okay, so let me jump over to the lab, and every time I typically like to just give a brief introduction to the material in the lab for the sake of nope. Or is it under here under repos? I never remember where anything is. Here it is. When do we have to have groups sorted by? Not this week. So I'll talk about groups probably next week. If you have some friends that you want to be in the same group as, send me an email sometime this week or sometime next week. They've got to be in the same class, but other than that, it should be fine. I think it's end of week 2, yeah. But it's kind of flexible because like I'm gonna be the ones probably like setting up all the groups and everything. So if people are kind of still undecided or there's a bit of mess, we can probably go an extra week. Like it's not too fast because you're not gonna get a project to week 4, so we have a bit of flexibility. We just kind of try to get everything done by week 2, mainly so that kind of we at least make sure that we're not going to be behind or we're not going to have group issues up to that point. Okay, so lab 1's pretty straightforward. You have splitter. Basically what you're going to do is you're going to read in a line for standard input consisting of words separated by spaces and print out the individual words in the string, right? Pretty similar to what we just wrote, right? And then you have satellite, which is a moon, planet, or machine that orbits a planet, or I wouldn't really say a planet or a star because you could technically have moons of moons, I think. So I would probably just say a celestial body. And in this exercise, you'll create a class that represents such as said satellite and use it to kind of have a look at a few things. And you can kind of look at all the various activities here. This is pretty straightforward as well. So pretty much you get given a structure and you're just going to be filling out a class. Yes, definitely, Reese. Okay, so hopefully it shouldn't be too crazy. Yeah. I'll show you how you can access that in a second. There's challenge exercises here as well. You don't have to do them. They're completely up to you if you want to do them or not. I kind of recommend maybe trying to do this one. The Scrabble one is just kind of like, it's not too useful other than like maybe to learn Java, and this is just kind of like design oriented. A good one to think about if you want something that's like very design focused is think about any code that you've written in the past and think about like how you'd add a new feature to that code and what would the complexities of adding that new feature be. And so if you can kind of think about that, it will help you a lot with designing it. Anyway.